This video is all about false color narrowband processing in Pixinsight, be it the Hubble palette, or also called SHO, be it the Forex palette, or any other color combination that you personally like. We will go through a ton of scripts, processes, tips and tricks to get to the color that you personally like the best. So let's get going right after the intro. Hey, this is View into Space. I'm Sascha from Switzerland, so grüezi miteinander and thanks for watching my channel. So I think there's a few things we have to discuss before we go to the computer. And the first thing is the term false color. Some people claim whatever we're doing with astrophotography, it's always pure art, given that we don't really know what the reality is, given we cannot fly there. So I would disagree. We are actually receiving photons, emissions, and amplifying them to display them. And an HA emission is red to the human eye, so if we amplify it, it will be red, and that's accurate. In the same way, an O3 emission is bluish, greenish to the human eye, and that's, if we amplify it, how it will look like. So with an RGB or HOO processing, we could state that we're really close to reality. Now we have to be clear, as soon as we're going now and giving these emissions different colors, we're deviating from reality, from the real emission colors. And even Hubble palette has a name and was used by NASA for the Hubble pictures. It doesn't make this palette any more realistic than any other random color that you want to give to these emissions. And I don't mean this in a negative way, but we shouldn't be held back by the Hubble palette to believe that we do something more scientific or more accurate if we're doing the Hubble palette than any other color combination. Just go out there, just look what's most beautiful to you and do it like this. And I will show you how to best select which palettes look best for your picture. Two other things I want to mention. First of all, from a processing point of view, it's not much different if you do HOO or HOS or a false color. So my HOO narrowband tutorial actually fits quite one-on-one to what we're doing here, except that we now also have Blur Exterminator. So do not expect any big surprises there. But the different tools and tricks to get to the colors that you want, that's the main focus what we're looking at here. And last but not least, we will use this data here, which is the Fighting Dragons of Ara, because I just love it. But I want to be clear here, this is not my data. This data was actually shot by Paul Hancock, and he has his own YouTube channel, The Polyman Astro. And I would absolutely recommend that you look at his YouTube videos. They're great, and we also will look at a script from him, how to do the Forex palette. With that, let's go to the computer. So welcome on my computer, and surprise, surprise, our first stop is not Pixinsight. Because as I mentioned, first we need to know what we want to do with our data. And for me, a great first stop is either Astrobin or Instagram. And just enter the object number or name and see what's coming, what other people are doing. And so here it's NGC 6188. And this is just one page out of many. But already here you see the huge variety. Do we want to have this bright blue with a bright yellow, a golden? Or do we rather want to go in a greenish matrix kind tone or something red? There's so many variations. And personally, I really like this bluish, intensive golden combination. And that's actually, this here is mine. This is what I was striving for. And you see still here, I did not completely match it. And it's actually a funny story. When I got the data from Paul, I did the whole processing twice, 2 evenings after each other, independently. But I was striving kind of for the same color combination. And still, 2 resulting pictures when I compared them afterwards, they were so different. So that's kind of the funny part. You can do this over and over and over again. And every time it will look a little bit different, and it's not more or less beautiful. It's just a different kind of beauty. So what are you doing when you know what you want to do? My recommended next stop is a wonderful page which actually Dylan O'Donnell from Star Stuff created. And at this point, I really want to thank him for that because it's an ingenious tool. So what you actually can do, you can enter here your HA, S2 and O3 picture, and it will give you all possible color combinations. The link to the page you find in the description below. But to do that, you have to consider a few things. First of all, the pictures have to be stretched. Second of all, they have to be no larger than 2 megabytes. They have to be JPEG, and they shouldn't be bigger than 1024 pixels wide. And you really have to do these things, otherwise it will not work. So there is a little bit an effort to do to make that happen. So I actually did them already. So here's my HA, my S2, and my oxygen. Then I say upload 3 images. And now here we have the results. Obviously they're not as beautiful as finished process pictures, but it just gives you an idea. So up here you have the pictures which use all 3 channels. And then below you have bicolor combinations. And again, everything is fair game. Whatever feels makes sense to you. So remember, what I liked most was actually the blue yellowish combination, and we see that here depicted also nicely with the Hubble palette. So for me that would be a confirmation to actually go further here with the Hubble palette. But tastes are different, and this is a great opportunity to figure out how you can actually come closest to what you like. So with that, we actually know how we want our end picture to look like, and we know how we actually have to combine our channels to achieve that. And with that, we can go now to Pixinsight. So welcome to Pixinsight. So let's have a look what we have and what we don't have. We have the 3 channel, HA, S2, and O3. And I already did a background extraction on these 3. I did nothing else. What we do not have is a luminance picture, and what we also don't have here are RGB stars. So we have to kind of deal with whatever is in here. And I will show you for both things how to cope with it. Let's start with the luminance picture. If you do not have a dedicated luminance picture, some people state they take HA, and others, and I belong to that, create a synthetic luminance picture. So how do you do that? Important is that you have actually saved these 3 pictures. Once you have saved them, you can actually go to Process, Image Integration, Image Integration. You click on Add File, choose these 3 pictures, open, and they're in here. So now comes the important part. Combination we leave on average, normalization, no normalization, weights, don't care, all weights 1. We do not do a pixel rejection, so we leave that and we let it run. And so here we go. We can actually close this, and this is now our luminance picture. So we call it like that, luminance, and 1 problem solved. Now how we deal with the star issue, I will show you in a second. The first thing what we do is now a linear fit. And we follow with that very closely the SHO tutorial that I already made. Because again, all we change actually are the colors. The rest stays about the same. So we go Process, Statistics. That's the first one which we need. We check all of them. The HA, we have a medium of 184. The O3, 140. And the S2, 101. So the S2 is the darkest. Now that we know that, we go to the linear fit. We drag and drop the S2 in the reference image, and we throw the triangle on the other 2. So on the HA and on the O3. So that's done. So now what we're going to do with them is a regular color combination. So here, channel combination, and we say the red is HA, green is O3, and blue is S2. Nothing special. We're executing, and here we go. Now, why did I do that? Because with a regular color combination, I can do SBCC with it. So we go to Script, Image Analysis, and then Image Solver. This is NGC 6188. Say OK. And here we go. And this image is solved. So now I can actually go to SPCC. So we leave this at average spiral galaxy, and we choose the filters. Given there's so much nebula in there, we actually want here to have a sample of the background. And with that, we let it run. These are nicely in the curve, so it looks okay. So we close it down, restretch it. So the star look okay here. So what we're now gonna do, we do blur exterminator. The stars look actually pretty small already, so I don't want to sharpen them too much. I even actually take it a little bit back here to about 0.1. That's enough. And I let it run. Okay. So next thing is the star exterminator. Generate star map. That's important because that's what we want. Throw it on there. Okay, and here we have our stars. Now there's two things to say to this picture. The first is, here we have some reminiscence from the nebula, which we obviously have to remove. For that, we take the clone stamp, click on the picture. We definitely need more than a 5. Let's go for a 20. We control click on the black area, move over here and remove this stuff. Okay, that's already good enough. Always remember to click here on the green hook, otherwise nothing is going to happen. Then we can close it down. Okay, nice. The other thing is, even we run SPCC, if we look at it, yuck, there's so much pink, magenta. And if you have seen my video, the uglify the stars, then you know there's a million of methods how we get rid of this magenta. But I'm not going to do that right now. And the reason is that it might actually fit, or it might not. And if it does not fit, perhaps bluish stars, which I can easily make out of the magenta stars, might fit. If not, I can make white stars out of it, yellow stars. I have a ton of options, but I don't know what really will be the best solution. So I'll keep it until the end, and then we'll see what star color we need that it fits nicely into the picture. But what I know for 100% is that I would get a million times better stars if I would have some RGB stars which were dedicatedly shot for this object. And that's again the lesson learned. So please, 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 if you want to really have the best pictures possible, take the time and shoot some RGB pictures. It really pays off because whatever we do here, it will be a compromise. It will never be as beautiful as RGB stars. With that, actually, we can start to gamble around and create some colors. And there's a million of ways how to do that. So let's start with the very easy tools. And if you look down here on my huge list here of processes, I have some pixel mask processes. There might be Bill Blanchard's, but I'm not sure anymore. But I will make them available to you. So please have a look at the link in the description for these pixel mask scripts. So here I have an SHO. This is obviously very easy. Here in the red we have S2, HA, and O3. So what we have to do that it works, we actually have to remove here the ABE. And when we have actually named them the right way, all I have to do is to throw the triangle on one of them here. And here we go. And here we have our SHO. So let's call this now SHO1. That's one way how you can do it. What we also have here is a Forex SHO. If you look a little bit at the script, that's more complex how it's calculated. Let's throw again the triangle on there. Let's have a look. And that's Forex. So let's call it like that. Forex1. Now there's two more little bit crazy ones. There's the Dreams Please that only uses the HA and the O3. But anyway, just to try it out, that you see. That's very, very reddish. Perhaps someone likes, I don't know, not me. Let's close this down. And we have Crazy Panda. That's a nice name. Also only uses HA and O3. Let's also try it out. And here it's more greenish red. So these are the options we have with these scripts here. There's also Forex only with HOO. I will not use that now. One possibility. Obviously, just saying you can actually achieve the same with the channel combination, at least from a SHO point of view. So if I now put SHO in here, I execute, and we compare that now with the SHO we have done before through pixel mask, they look exactly, 100% exactly the same. So both ways are going. With Forex, only pixel mask goes because there's a complex formula behind it. So the next thing which we can come to SHO, and this is now really cool, is a script called SHOAIP. I stumbled by accident over that, and I had actually to search quite a long time until I found the link to the repository. Some people even said it does not exist anymore, but it still exists. So if you open this, you get to this screen. So you can do like everything here. It's really amazing. So you can give it a luminance picture, an SHO, an S2, an HA, and an O3. That's already correct. You can even add here RGB. The V, it's from French vert. You can even do background auto equalize. You can stretch it automatically. There's a million of things. And even if you look down here, you can actually per channel, you can adjust the things again. So at the moment it's 100%, whatever it is. But I could now even create here mixes per channel. So it's practically limitless. And there's even more things to change here. And quite honestly, I have not 100% grasped all of the option that you have, but you can also choose your chroma noise reduction. And when you're ready, you just say mix, and here we go. And that's what it created. So the SHO version, this script created, is a little bit less colorful than what you get by standard. But if you really take the effort and look into that script, then you can create about anything you want. So it's much, much more powerful than just regular pixel math, and you have the full control. So given that it's free, I think it's quite something interesting to look into it. But for the moment, this is not our favorite. So the next thing I want to show you has to do with SHO. When you have actually already an SHO picture combined, you can use a pixel mask script of Bill Blanchard, and that is called SHO Normalisation. You might have already seen the SHO Normalisation. What you can do there, when you have actually a regular picture, you could throw it on there and it creates a fake SHO picture out of it. So we can actually try that here. So that, for example, would now be our regular HOO picture. If we now open the script and throw it on there, we get something like SHO out of it. My personal opinion about that, if you want to do SHO, get the S. Because it's kind of ridiculous doing something which really has the emphasis on the S if you don't have the S. So I have a little bit an issue with that script based on that. And for everybody who has an one-shot color camera like I also have, if you say, well, we cannot get the S, actually now you can with the ASCAR Color Magic D2 filter, which is a dual narrowband filter which records O3 and S2, and in combination with a normal narrowband filter, you have then actually the whole palette, the whole 3 channels, like you would have with mono. And I have a dedicated video to actually show you how it works. But it works actually pretty well, and so I can absolutely recommend this filter. Now, if you have this SHO, and we go now to the SHO normalization of Bill, let me just make a duplicate, throw it on there. And you see it doesn't have made a lot, but still there's a difference. It's now less reddish, it's more greenish. And for example, if you look here, the green blue is much more intense than here. So it depends from picture to picture. But I have seen really massive improvements through that script. But what I have also seen is that sometimes it blows out details. And when that happens, you can actually go back here in the symbols and start to decrease these values. And by decreasing them, you can get to a level where it doesn't blow out some details. But here it's good. And I prefer this here, which has lost some of the red, but actually emphasizes on the green than this one. So I will continue with this one. Let's call this SHO Normalized. So last but not least, from a pixel mass or script point of view, what we have is actually the very new Forex script from Polyman Astro. So the little issue that it has is that it needs stretched monopictures to work. And why I say issue is simply that it's quite a lot of work to actually stretch all three. But I had a short talk with Paul about the reasoning, and he states that the Forex formula really works perfectly. You have to work with nonlinear pictures. So I will do that right now. I will stretch the three mono pictures and then we continue. So in the meantime, I've actually removed the stars and stretched all of them. So now let's try the Forex script. So we go to Script, Utilities, and when we have actually installed it, we find it here, Forex Palette Utility. We open it up, choose this option if you have 3 channels. That's what we have. And we do not have stars images here. We only want actually to have the nebula. So we add whatever is needed here. Then we say execute. We let it work. And here we go. So when we compare now the result we have from the Forex script and the one we have from the Forex pixel math, it is a substantial difference. Personally, I like the script much better. But again, personally, if you want to show the gates of hell or I don't know, it looks also interesting. And we will see further down the line, there might also be other ways how we can use this picture. But definitely great to have this script of Polyastro. And so if you want to have Forex, it might really make sense to go the effort and stretch the 3 mono picture to get to this awesome result. So what do we have right now? We have the 2 Forex pictures and we have the 2 SHO pictures. This one, the normalized one, and this one, the not normalized one. So for the moment, with the Forex, I will go on with both. When it comes to the SHO, they're both interesting, but I will now go on with the normalized one, and I will say for the moment, goodbye to the Pixel Math SHO. So what's our next step for these 3 pictures? From my perspective, it's Blur Exterminator. But again, this is optional. If somebody does not like Blur Exterminator, be my guest, do not use it. So there are different issues we have now. For these 2 pictures, they're not stretched yet, so it's perfect as Russ says it should be done. The only problem is we do not have any stars in there anymore. What this means, if we open now the Blur Exterminator, we have to go out of the automatic PSF and we have to enter it manually. So how can we enter it manually when we don't have any stars? Well, we still have our star picture, and you can use one of the many methods actually to measure it here. And then I know now with this it's 2.4. So once we have done that, we can throw it on there. And we also do it here with the Forex. And quite honestly, the changes are minuscule here. Now with the Polyastro picture, there's another issue. This is now already stretched. And when you remember, Russ says very clearly, do use Blur Exterminator in linear form. Now, there's a little caveat. He also says it also works when you do linear stretching. So not GHS or ArcSyn. Then it also works quite well. So this is why I stretched in a linear form with the screen transfer function and did not use my favorite options, GHS. So now I can very easily also apply here the Blur Exterminator. So now this next step is Noise Exterminator or any denoising solution. So we have quite some substantial noise in here. Don't want to go up that much, but let's go 0.8. Just throw it on there. Number 1, number 2, and number 3. And this is done too. So now we have to stretch the other 2 and we have to stretch actually the star picture. So let's start with the SHO star picture. We remove here the auto stretch. We go to the generalized hyperbolic stretch. Let's open a preview. We press here on the plus sign, go to the right of the curve, like this, say send to SP. We remove here the zoom. We go to the local intensity, go to about a 10. And again, as always, when I do that, the generalized hyperbolic stretch, it's really worth doing it. It's much superior to simply a linear stretch, but it's complex. And it would take another 30-minute tutorial to explain that fully to you here. So you can see a little bit how I do it, but if you're not used to the generalized hyperbolic stretch, I would really recommend that you look in YouTube to an extensive tutorial. I don't have actually at the moment one, but there are good ones out there, and just really look into it. So now with the local intensity on 10, we now go up here with the stretch factor to about here. Press the execution button. We reset it. Set again. Send to SP. We go to about a 5 or 6. Move it up again. And you see how nice it comes. So again, we execute, reset, can set it again, send to SP. Now we go with local intensity to about a 3. It's too much, but that looks beautiful. Can also compare. Yeah, there's really a lot of glow in there. That's exactly what we want. Let's do that. Now we actually go here to the middle, send to SP, because I feel the surroundings are still a little bit too dark. So to actually do that, I go up here and get here about to a 3 again. And let's just brighten it up a little bit more. We're actually protecting the highlights now, just to absolutely ensure we're not going here too high. And I think that's great. So we execute again. Next thing, we're going linear, and we simply in the low clip, we enter 1 on the last digit. You see it gets much darker. That's a little bit too dark, but now we know how dark we could go. That's dark enough. So I execute again, and that's it. And that's stretched. Now I have to do the next. In the interest of time, I will not show you. I will simply do that. Okay, and here we have now our Forex stretch picture. We have also to stretch the stars. Now with the stars, as you know, if I have RGB stars, I will first use the arcsine stretch and only then go to the generalized hyperbolic stretch. Here, because I have to work with the rather suboptimal stars from the narrowband pictures, I will simply do a generalized hyperbolic stretch because we don't really want even more colors. They're already colorful enough. Let's put it like this, nicely. So in principle, it's exactly the same here as with the nebula. It just goes a little bit faster. And we really don't want that much stars here. So from my taste, this is already good enough. And that's our stars. Do we have everything now? No, we're still missing the loom picture. Now, did you keep track where we are with this one? We also have to apply here the blur exterminator. Here we also go with 2.4, but here we say correct first. Okay, that's great. Then we also need here the noise exterminator. We also need to remove the stars here. Okay, and now we also have to stretch it. Same procedure as before. So now we have definitely everything stretched. So let's look again what we have. We have a very greenish picture. We have a very reddish picture. We have some rust red with some blue. But remember what we actually wanted? This is what we want. The blue together with the yellow. And our pictures here, they look far from that. So how do we go from here to here? So we are about halfway in now, and I would like to interrupt this tutorial for a short message from our sponsor, which is myself. And in exchange, I will not bother you with any YouTube commercials. As you have already seen and will still see, there's so many different ways of doing false color processing that wouldn't it be nice if you would have everything we cover in this video on a nice sheet. And wouldn't it be nice not to have it only for this session, but also all the other workflows, in-depth tips and tricks of the blur exterminator, for example, and on and on and on. And the good news is you can have all of that for the price of a coffee at my Patreon page. Link is in the description below. And now let's go on in Pixinsight. And now comes the really interesting part when we start to play with colors. You know, until now it was pretty much formalized, using scripts and pixel math, but now we have all the liberty. So what can we do? First of all, we're gonna clone this one, and we simply and easily throw SNCR on it. Because you know what SNCR does? It removes the green, right? I use here the SNCR of Bill, but you can also use the regular one. And look at that. Doesn't it look already much, much different? We still don't have the yellow that we want, but we definitely have gone rid of all this hideous green, and we have the blue. So how do we get to the yellow? Now here we have to go into the basic color composition. How do you get yellow when you have green? Well, green plus red gives yellow. Does that bring you to an idea? Well, let's try it. Let's go pixel mask. We can go into expression editor. We have here the Forex 1 plus the SHO N. Well, let's just take that over here. Now we obviously don't want to duplicate how bright it is. So we divide both by 2. We throw it on there. And we have the yellow. Now we could actually say this is still too much orange, so I can now play with these numbers. So for example, I divide here the red by 2.2, and I give it actually more of the green, 1.8. So remember how it looked like. We throw this now on there, and it's actually more of the greenish yellow. So that's nice. So we don't need that anymore. Let's assume we do not need this here. We continue working with this too. But we have now 2 pictures. In this here, it's really the blues who are really, really nice. In this one, it's actually more of the yellows, which are nice. Can we use kind of the yellow, but actually we don't like here the green. It's too green. It should stay that blue. So what can we do? Let's use curves for that. So if I now put a preview on and I go in use, I select here some control points, because we don't want that just like everything moves around. Let's keep at the moment everything as it is. So now the first thing we want to do here, we want to get here more blue and less of this greenish stuff. So we click on here and we see actually where the line crosses. It's about here. And what we do now, we try out what's happening when we move this around. And you see when we move it here, this part here gets much more blue. You can switch green, blue, green, blue. Good. We execute that. Now another nice tool we have coded by Bill Blanchard, the color mask. So here I have the blue color mask. So I throw it now here on the one where I have the blues. So now what we're going to do is we throw this color mask here on the other picture now. Okay. So it's actually on here. I only have it hidden so that we actually see what we're doing. Now we need the pixel math again. Get again the clone and normal one. And we actually want to use mostly the clone one. So we can say we want to have the clone one times 8 plus the normal one times 2. Obviously the whole thing divided by 10. That we get to the normal brightness again. We throw it on here and look at this. The blue is here. Looks really nice. So we can close that down. And we're finally at 1 picture. We're not completely there yet, but we're very close now at what we want. And if you're now saying, are you crazy? This is way too complicated. You could have achieved that easier. Yeah, maybe. But that's not the point. The point is that I really wanted to show you the full variety of things you can do to these pictures to get to what you want. So you have the SCNR. You have the color masks. You have pixel math, where you can add, deduct. You can do this in a masked way. So you have so many options. And that's for me kind of the creative process. The rest is a rather rigid workflow to add the contrast, the luminance to whatever. But this is the fun part. This is where you define the colors. And as we said at the beginning, you have all the freedom in the world to do what you want. So we're here now in the curve transformation. So we can first, in the standard way, work a little bit at the picture. That looks okay. So now we can actually go into saturation. And in saturation, let's also put some control points that we don't mess the whole thing up. We can actually enhance the yellows. We can enhance the blues. We can go a little bit down with the greens. See what we've done. It is subtle, but it has its effect. And if I do this a little bit more, then even more, we get more of the yellows and less of the greens. We don't want to have them completely erased, but they're now less visible. So that's nice. Let's do that. And with that, color-wise, I think we're pretty good. It's what we wanted, at least what I wanted for this example here. So now it's actually time to combine this here with our luminance picture. What we need to do now here is actually to convolute it. Convolution. We're also getting a preview. We don't have to overdo it. So that's already good here. So we let this run. And if you're asking why we're actually messing this picture up, why we convolute it, the reason is that the luminance gives now the information, so the sharpness, the contrast. And here we only provide the colors. And if you would leave it sharp, actually given we worked here a lot with the colors, it might not completely fill it in the structure. So we fully rely here on our luminance picture to actually provide the sharpness. So now to combine it, we go to the LRGB combination. We actually deselect here the RGB. We leave the chrominance noise reduction on. We provide here now the luminance and we throw it on the color picture. And here we go. We can minimize the luminance picture, and here is now our LRGB picture. And with that, we continue to work. So the next thing we're going to do with it is we let it glow. For that, we use the exponential transformation, and you'll easily see what it actually does. It makes it brighter, but it makes it brighter more on the brighter parts than on the darker parts. Still, we don't want to overdo that. That's already good enough, but just a little bit more pop. So that's great. We close this down. Then we want to add some contrast. For that, we go to the local histogram equalization. These are all crazy names, but in principle, it's contrast. Again, we want a preview. And this is always shocking when you first go in and you think, no, let's go out of there again. No, just the only thing you have to do, contrast limit, you go to 1.3. It's kind of a magic number, which always works. It's kind of funny. That should be the default here. Kernel radius, we want to first work on the large structure. So you go to about 150, 140. And now you see it already looks much better, but it's still too strong. So we're actually going down here with the amount to about 50. And even that I feel is a little bit too much. So we go down more. And that's great. So let's execute that. We now go down to about 50 here in the kernel radius to actually address the small structure. To actually really see what we're doing, we can increase the amount again. And you see again a massive change, which we don't want, but we see it works. So we go again, we minimize it, 300. And that's already good enough. We don't want to overprocess this picture. We want to just give them this little additional kick. Okay, close the preview down. Now last but not least, we just go back to our curve tool. When I look now at the picture, I think it's too bright. These structures, personally, I don't like them. I want to have them much darker, because this is anyway a little bit, in quotes, a problem of this nebula, that it has almost no dark sky. It's nebula all over. And at least here, I would like to have it a little bit darker. And by the way, also something interesting is, you see here, I think this is still some gradient, quite honestly. And this is just something which I personally find it's hard to actually do the background extraction on grayscale pictures. A lot of time I actually struggle to see if the gradient is really out or not. And probably what we should have done is right after the color combination, when this was actually visible, then to do another background extraction, but so be it. So we go again in curve transformation, some control points. So the only thing I want to do is to make it a little bit darker. That looks already nice, so execute that, and that's it. Okay, the picture is ready. The only thing that's obviously still missing are the stars. Now, in all these million of pictures we have in the meantime collected, here are the stars. They are ready. If you have seen my HOO tutorial, you've seen that I kind of masked the nebula so that the stars would actually only be where the nebula isn't. Now, I think you see the problem here. The nebula is everywhere. So should I mask everything? Shouldn't we do any stars in it? It's, by the way, an option with this nebula. I feel it's absolutely valid to display this without the stars. But otherwise, we have to be consistent and just put them everywhere. Here, there's no way from my point of view where you could select where to do stars and where not. And again, remember what we said when we looked at the pinkish stars? Let's see now how it looks like. If it's okay, or if you have to change a little bit the star color to make it appropriate. So we give it a try. So I have here my integration script. So the starless is now called SHO _n. The other one is stars. And let's just try it as a default and see what we get. And I would say the pinkish stars really look a little bit strange because it's the only thing then that is pink. Let's undo. I told you it's really easy. All we have to do to get rid of the pink is we invert the picture. Here we go. We take SNCR, throw it on there. And by the way, you know, SNCR is just a standard process you always use to get rid of the greenish hue. But now you see how much creative potential you have with SNCR. So you invert it again, and all the magenta stuff is gone. Now we throw it on here again. I feel that looks better. The pink was kind of really, it just didn't make any sense here. And with that, we actually are finished. This is our final picture here. And now let's compare it to the picture that I already made. And you see it looks completely different again. It's similar. We have here the blue, we have here the yellow, but the yellow here is much fainter. It's more greenish. This is much more reddish. We have it here much brighter, while it's here a lot darker. Probably at the moment I prefer my original one, but this is nice too. But that's what I was saying at the beginning. You can do this process 10 times, night after night after night, and you get to 10 different pictures. So that was it. It was a lot of different ways. And if I should sum this now all up, then what I really want to tell you is be creative. Astrophotography is to a large part art, and here with the false color especially. And so to go away from the traditional colors, but also go away from the SHO, which everybody does, and try to combine color palettes to get to new levels. I think that really will make your photos unique and stick out of the mass. And I think with all the scripts and tools and tricks I showed you, you have all the tools set that you need to accomplish that. And I wish you much success with it. With that, see you and clear skies.